Hi guys, welcome back to my YouTube channel. Today we will be doing this GCSE question. This is a very hard question. It was the last question on the 2023 paper. So it was question 24. So this involves inequalities and quadratics and lots of complex equations. So let's get into it. So question says, find the set of possible values for x from which 4x squared minus 25 is less than 0 and 12 minus 5x minus 3x squared is more than 0. Okay, so first of all, you can see that it says find the set of possible values. So when it's possible values, you always know you're going to write as inequality, because what possible means is it could be something or it could be something else either. There's different values it could be. So what we can do is, if we write these two inequalities as one inequality, because if you see this, we need to get a value that is less than 0, and this, we need to get a value that's more than 0. So if we write it as one inequality is less than 0, and then we write another less than 12 minus 5x minus 3x squared. So now that we've got this, we need to simplify this equation and this equation. So first, let's do this one. So 4x squared minus 25. So if you look at this closely, this is a difference of two squares. This means that this one is a square number and this one was also a square number. So if there's a difference of two squares, all you do is you square root both of the terms and put them into brackets as a plus and a minus. So here you would have 2x minus 5, and your other bracket would be 2x plus 5. So now you have two brackets that could possibly be x. So if we solve both of these, so we put this as 2x minus 5 equals 0, 2x equals 5, so x equals 5 over 2. If you look at our inequality again, this has to be less than 0, so this answer cannot be possible. So if we try this, we have 2x plus 5 equals 0. So then 2x equals minus 5. So x equals minus 5 over 2. So this is possible because it's less than 0. So we know here we can write minus 5 over 2 for our first part of our answer. Now we just need this side. So here's our another quadratic equation. And first of all, we want to put it in the right form, because for a quadratic, the right form is ax squared plus bx plus c. This is how we solve our equation. So put this into the right form, we have a negative 3x squared, then negative 5x, and then a plus 12. So now if we solve this, we need two numbers to make minus 5, and one number or two numbers to make times to make positive 12. So if we try, first of all, what we need to do is, instead of having a 12, because there's an exponent, because there's a number in front of the x, you have to times the 3 by the 12. So if we solve this, we need two numbers that add to make negative 5, and two numbers that times to make 36. So that would be 9 and 4. But if we do 9 plus 4, it would not equal to minus 5. So if we try minus 9 and 4, that does work. So if we do that, minus 9 and 4, so now what we have to do is we put it into another equation where we split up the minus 5x into a minus 9x and a plus 4x. So all we've done is simplified it further. So we add 12, this 12 comes down here, and now we factorize into two brackets. So first of all, we can take out the minus 3x, because that's common between both of them, and we're left with x plus 3. So if that's x plus 3, you know our other bracket is also going to be x plus 3, and then a number type that would multiply here to make 4x plus 12, which is 4. So now we have our two equations, minus 3x plus 4 and x plus 3. So those are our two equations. So which one of these is more than 0? So to find that, what we do is we solve it like we solved before. So minus 3x plus 4 equals 0. So minus 3x equals minus 4. and then x is minus 4 over 3. So that could be a possibility. And then x plus 3 would just be x equals negative 3. So, okay, so now that we've got minus 4 over minus 3, that's the same as 4 over 3. And that's also a minus 3. So we know 4 over 3 would be the round. So all we do is we put as inequality minus 2.5 is less than 0, which is less than 4 over 3. You could even try this if you want to, because these inequalities would solve both inequalities that we have here. So they would both solve this equation and this equation. They would both be able to satisfy all of these values. So that was it for this video, guys. Thank you for watching, and appreciate it if you subscribe and leave any comments down below. And if you have any requests, you can comment and I'll make a video on that. Okay, bye guys.